Dear students, question is obtain an 8:1 mux with a dual 4:1 mux having separate enable inputs but common selection lines. Use a block diagram construction. So we know simply 8:1 mux design, right? But here the 8:1 mux designed with the dual of 4:1 mux having enable input also, separate enable input but common selection lines. So first we should know the multiplexer concept. So 8:1 mux means it's nothing but 2 power n is to 1, which accepts the 2 power n number of input and produces the single output. That output will select the particular input based on the selection line combinations, right? So for 8:1 mux it requires the 3 selection line because 2 power 3 equal to 8. So the 3 selection line is required for this 8:1 mux. So the 3 selection line is nothing but S2, S1, S0. So it provides the 8 possibility from 0, 0 to 1, 1, 1. So if selection line 0, 0, 0, then the output will be the input I0. So likewise, selection line is 1, 1, 0 combination, the output will be the I6 input line, right? Let's see the block diagram construction, how the 8:1 mux is designed by the dual 4:1 mux. So here they mention the dual 4:1 mux, so we have to take a 2 4:1 mux. For 4:1 mux, it receives the 4 inputs and 2 selection lines, right? So this mux also 4 input and 2 selection lines. So totally it covers the 8 input from I0 to I7, right? I0 to I7, and the uses a common selection line. S0, S1 is common selection line. We know 4:1 mux, if S0, S1, 0, 0 combination, the output will be the I0. 0, 1 output is I1, 1, 0, I2, 1, 1, I3. So here also S0, S1, 0, 0, I4. But here the what is the problem means S0, S1, 0, 0 means here also S0, S1, 0, 0 because common selection line. Then which the output will decide which input, whether I0 or I4. It very confusing, right? So that here we are using a separate enable input for these two muxes. So this is enable input 1 and this is enable input 2. Here one inverter is added with this enable input 1. This enable in is considered as a S2, right? S2. If S2 0, then what happen? Which mux will be enabled? If S2 equal to 0, then which mux is enabled? S0 means enable input 2 is 0. This 0 is given to enable input 1. So it's become a 1 because here we are used the inverter. So enable input active. So this particular mux only enabled. This mux is disabled. Then this mux enable means based on that selection lines, the output will decide any one input, right? If suppose I am giving S2 equal to 1, then which mux will be enabled? If S2 equal to 1 means enable 2 become 1 and this enable 1 become 0. So this mux is deactivate and this mux is activate. Now based upon this selection line, it will select the particular input. So now check with this truth table with this block diagram, right? S2 0, S1 0 0. So S2 0 means this mux is enabled. Then the input selection line combination is 0 0. Then the output will decide the I0 input, right? So all these first 4 combination 4:1 mux, this first mux will be enabled. The remaining 4 combinations second mux will be enabled, right? So our total overall output for 8:1 mux Y is combining these two output, which is nothing but Y equal to S0, S1, S2 bar into I0 plus S0, S1, S2 bar I1 plus I2 is S0 bar, S1, S2 bar I2. I3 is S0, S1, S2 bar I3 plus I4 is S0 bar, S1 bar, S2. S0 bar, S1 bar, S2. This is I4. Then I5 is S0 plus, S0, S1 bar, S2 into I5 plus I6 is S0 bar, S1, S2. S0 bar, S1, S2, I6. I7 is all 1. S0, S1, S2, I7. So this is the 8:1 mux output, single output using the dual 4:1 mux.